Thank you, and SEDS for the invitation here. I love the words that you used, Trevor, of passion, because one thing I love about SEDS is that there's a bunch of passionate folks about space, and one thing you'll find about myself and also the company AGI is that we are extremely passionate about space. We're a bunch of space geeks. Coincidentally, SEDS I've been working with the universities for probably the last 5 years now, 4 or 5 years, and SEDS was actually one of the very first schools and SEDS chapters that I visited way back when. So it's nice to join and support SEDS any way I can. And like you, Trevor, I do look forward to being able to meet back in person, face to face with all the different students and everything. And interesting, I guess, is meeting a lot of new students now, because I guess over the past year of pandemic quarantine, we've missed a lot of people. I've missed a lot of people. So today I'm going to talk about, a little bit about AGI and our product STK. This can be as interactive as you want. So if you have any questions, please pipe up and feel free to ask those, or put them into the chat there, and I will address them as well as I can. But again, so one of the things we're going to talk about, passion, because, and I'm going to talk about one of my passions, of course, and my passion is space. And one of the things I'm very passionate about is what the company I work for, AGI, does and how it's related to space. So first off, who is AGI? Especially students who, if there are students here that are especially first or second year, you might not have heard of AGI or our product STK. But we've been around for 32, 33 years now. One change, though, it's not going to affect, or there's not going to be any negative impact. There will be a lot of positive impact. But at the end of 2020, AGI was acquired by a company called ANSYS. For those maybe in mechanical engineering or civil engineering or some of the other engineering disciplines, you probably know ANSYS of some of their physics-based tools. But AGI is now part of ANSYS. But the basic part of AGI is that we are a bunch of space geeks. We love space, and for the most part, and this is probably the fun part about AGI and our product, is that there probably has not been a space-related mission in the past 15, 20 years that hasn't used STK, Systems Toolkit, the software we're going to talk about in a few minutes here, in some fashion for their operations. So it's kind of interesting. Every time you see a space mission, it's like, oh yeah, well, they're using STK. They're using STK, and so it makes, of course, it makes it exciting, but it sort of feeds the passion that we have for space, is that saying, hey, here's all the work that we've been doing. Here's all the excitement. It actually shows that, being able to express this excitement, say, oh man, look at that. That's something that we help do. And AGI is a different company, and I'll tell you, though we do things in space, but we say, hey, we are like no other company on Earth. And what makes a difference with AGI is that, again, I'm going to use this word again. It's a word I use a lot when I speak with students, is passion. We're passionate about what we do. And one of the things I always, I think when I did the space symposium last year, I told, one of the things I told students then was, to find out what you're passionate about, and follow those dreams, follow the passion. If it's space, that's great. If it's something else, that's okay too. But in our case, we love space. So let's talk about STK or Systems Toolkit. We're probably known mostly as STK. Probably about 10 years ago, the name was changed from Satellite Toolkit to Systems Toolkit. Now, the reason for that change is, as I just mentioned earlier a few minutes ago, that virtually every mission in every space-related mission is using STK in one fashion or the other. But we are not just limited to space. Basically, anything that moves through space, not like in outer space, but X, Y, Z, positional space and time, you can use SDK for. So if you're building a launch vehicle, or you have a UAV, you have an aircraft, you have a remote controlled vehicle, and you want to show how it moves over time, you can use that SDK. Now, so I'm gonna talk broadly here about SDK and try to apply that to how this might help you individually. So, for example, one of the things that a lot of groups like SEDS, they build CubeSats, or they design CubeSats. Well, SDK is the ideal tool for that, in that you can, so when you're building a CubeSat, you say, okay, I'm putting a CubeSat up. There are a couple things that I'm probably going to be doing with the CubeSat. One is that it's going to have some kind of payload, because I'm assuming I'm not just sending a box up just to fly around. So it's going to have a payload. So the payload could be, a camera, some kind of sensor, or something that's measuring something. But with that, you're going to have some way to communicate with it, because why send something up if you can't communicate with it? And along with, since you have a payload, it's going to have some power requirements. So then you're going to design, so okay, well, I'm going to either have some batteries, long-lasting batteries, or most likely I'm going to put some type of I'm going to put a solar arrays on the CubeSat. In addition, if you have some kind of payload, you generally hope, or you want some type of attitude control, positional control of the satellite, or some type of way that if it's a camera, hopefully it's pointing in the right direction, or or for example, for the solar arrays, are they getting sufficient illumination by the sun to power the subsystems of the CubeSat? And so every one of those steps, every one of those capabilities, you can do with SDK, and it makes it easy to understand. And especially as you do a sort of a rolling all these different systems together, you can start using the capabilities, all the different functionality of SDK. So we talked about, hey, you're going to have a payload. So let's assume you have a camera. Well, you can say, well, if I have a camera, and this is the field of view of the camera, and in this case, let's assume you're taking pictures of the surface of the Earth. You can say, well, what can my camera see? When can it see it? Some of the important things, especially if you have an optical sensor, is, do I have to worry about the sun ever blinding my camera? One is, first off, you probably don't want that to happen, because it would, probably the more important reason you don't want that to happen is that it could burn out your sensor, your optical sensor. So you say, okay, well, in the design of my orbit for this particular CubeSat mission, do I have to worry about the sun ever, shining or illuminating my sensor? Or what do I have to do to mitigate that? And then you could work with, okay, well, I'm going to assume I'm going to have some type of attitude control system. So you can model an attitude control system for your CubeSat and say, okay, well, based on the control law that I built into my attitude control system, will that minimize the risk of my sensor being blinded by the sun? Or the opposite is true. I mean, you can use the other side too. Assume you had a sensor that, you want a sensor to point at some, some celestial body, and say, well, will the attitude control system or the default attitude of the satellite allow my sensor to see, hey, I'm tracking stars, or I'm tracking the moon, or something like that? Will you be able to see that? And then that type of analysis can be done with SDK. We talked about the solar arrays. So depending on where you put the solar arrays, if the solar arrays are all around the CubeSat, you can probably assume that that you're going to get some illumination all the time that it's in sunlight. But you can, based on the predicted orbit that you're going to be in, the predicted altitude you're going to be in, and the predicted attitude your satellite is in, you can then use SDK to determine how much illumination are my solar arrays receiving. And then from that, you can determine, will I, what is my budget, my energy budget? So I say, if I'm, let's assume 100% of my solar arrays, I'm only getting 25% illumination over a particular orbit or over a period of time. How does that impact my power budget? Again, very straightforward, a very easy thing to do with SDK. We talked about communications, like a payload or a communications payload. Well, why put a satellite up if you can't communicate with it? Get some kind of information up. Otherwise, it's just a flying brick, not doing something. So so if you put a communications payload in, and you want to be, assuming you want to be able to talk to it. So like, hey, you're planning to build a ground station in Ann Arbor, and so one of the things you want to do is like, okay, well, here's my transmitter, here's my receiver, this is the frequency, this is the type of antenna I'm using. And so the question is, well, can I model? You can model the antenna and the transmitter to such that, will there be sufficient energy to communicate with my satellite? In addition, so I'm on the ground station, I have again, I have a CubeSat up there. I can say, well, I can determine when I'm seeing when the CubeSat will be flying over Ann Arbor, one, and when it is flying over Ann Arbor, would there be sufficient receive or transmit energy that I'll be able, is there sufficient transmit energy such I'll be able to receive the signal? You can even go down further with that in the communications analysis. Is that, let's assume that if your payload, assume you're collecting some kind of information, and you store that information, so when it's over the ground station, then you initiate a download. Well, based on your frequency and based on the energy, you can also determine what kind of bandwidth can I expect to get out of this channel, or this frequency in the antenna or the design I've made, would I be able to collect all the information that I collected over several orbits over a period of time. So SDK, sort of, if it has any, sometimes this is a big jump here, but if it has anything to do with space, or anything to do with a satellite or something like that, STK can do it. Now, so the most interesting part is, especially those who have not used STK before, is the software is available to you as students. It's available at no cost. In normal times, in pre-pandemic times, I would personally actually be out at in Ann Arbor 2 or 3, probably 2 times, maybe 3 times a semester. And one of the things that we do is training on our product. And so we'll do hands-on training to help you and your faculty members to use SDK. SDK, again, one of the reasons, probably and as students, other than this is really, 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 really fun software, probably one of the main reasons, or one of the important reasons that you want to use STK is, as I said, virtually every space mission out there for the last 15 years uses SDK in one fashion or the other. But it's a great skill. One of the things I also do, again, last year at the Space Symposium, I did a resume workshop. I work with our recruiting side, looking for interns and full-time employees. But one of the things I stress to students is, because virtually everybody in the aerospace world uses SDK, all the companies out there, this is something that you want on your resume. So experience training with SDK is a great capability, just like you might have MATLAB or Python or some other engineering software application skill sets on your resume. One of the things you really want, again, if you're passionate about space, you want STK on there. And we offer, as I mentioned, we do on-site training. We're planning to be doing on-site training back in the fall again. But we also have online resources, and we have some testing where you can become certified in SDK. So you can, get on your resume, you can say, hey, I'm certified at some certain level with SDK. Again, a great thing to have on your resume. Of course, I have a bias on that because I work for the company, but I think this is probably one of the more important things is learning a skill set, learning a software tool that is used, in industry. And SDK is one of those. So, sometimes it's hard just to talk about SDK and without doing a demo. But I'm actually going to do it slightly different. I'm going to actually, if those who, well, in the industry, a lot of people who don't use SDK directly generally know us as, oh, you have these great videos, you make these, I see these great images. It's because, back to your, back to SDK, is that we do all the physics. I mean, all the hard stuff is there, but the name of AGI, again, I don't know if I clearly mentioned, it's called Analytical Graphics. And the reason, and we've always, and that's been since, of course, our inception as a company, but the term analytical graphics is that, when you're trying to do things in 4 dimensions, position and time, sometimes it's hard to figure out where is something in time. If I have my globe here, my satellite, and say, okay, well, what can see what? And at this time, and if it's just 2 objects, it's sometimes easier. But then again, if you try to do multiple objects and do it over time, it gets confusing. So the term analytical graphics is that we want to do all this, we do all the physics, all the math behind it, but it actually pops back up to show you a picture so that you can visually confirm or visually see what the analysis is you're going to do. And so a lot of times, a lot of the things that we do, when people are showing the information from SDK, it comes out in a picture or a video, which I'm going to show you one in a few seconds here. And one quick story before I cue up the video here is that I was doing a training class for one of the senior design courses at a university, and I was talking to one of the students and asked him why he was interested in taking this SDK class, and this was for his senior design class. And his statement is that we just came back, we just finished our first presentations of the reviews of everybody's project. He said of the 5 teams, 1 team used SDK to visualize what they were doing, and everybody else just sort of used flat pictures or things in PowerPoint. And he said, his comment to me was, he said, that team's project was probably the worst project, in the class, but he said, God, it looked really, 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 really nice. He said, the next time we do it, next time we do our design review, we are going to be using it SDK so we can show what we're doing. So I'm going to queue up a video here, and again, this video I'm going to show you is basically everything you see in here was generated using STK. And I mean, there's some minor post-processing editing done. That's just basically some of the text image overlays that you're going to see. I actually did a last-minute change on this video because I was re-looking at the calendar and seeing that we are in May here. But we're a couple of days past this, but you'll see what I'm talking about once you see the video here. So there is no audio on the video, and so if you have any questions, I'll probably talk a little bit as we go over the video here. So here we go. So being 4 days after May the 4th, I thought this video would be appropriate. So again, this was done completely in SDK. So making videos to describe what's going on is one of the powerful capabilities of SDK. So using OpenPress, we tried to determine what the mass of the Death Star would be. This is the first Death Star. And using capabilities in SDK, we wanted to determine, because it has some mass to it, we wanted to determine how it would impact, figuratively and literally, the different orbits as it approaches the Earth that it comes in. And so since the Death Star actually has some mass here, you can see actually it is perturbing the orbits of the satellites as it flies around. Again, analytically, the physics of this was using STK. This is not, I mean, of course, this is a all a made-up scenario here, but the actual physics to determine how the orbits would be perturbed based on what we could determine the mass of the Death Star would be is accurate here. You can almost see if the Death Star did come into orbit around the Earth, it would you know, literally and figuratively perturb, the satellites, again, from its mass. So that's just a quick understanding, that, what can SDK do? Well, SDK can do that. And that's the fun thing. And, the visualization, another way I tell people is that it's the very tip of the iceberg. It's because all the physics, all the math, all the design, all the engineering is sort of done beneath that. And this just shows you, so now you can show what your project's doing, what you're trying to, what you're trying to propose, will it work? But you can show it to people who might not understand all the physics or the all the engineering that goes into that, but quickly understand, hey, this is what my mission, this is what I'm trying to do. So one of the, so back to, so what can I do to learn STK? Well, we have online training resources, and in working with, in conjunction with SEDS we hope to be, I really hope, and I assume you do too, hopefully back in the fall here, we will be doing on-site training. But again, I can work with you to get, you can get access to the software now if you're interested in it, because it is available to you as students at University of Michigan. Here's my contact information. Here's my phone number. I'm going to also do another plug here is, the good news is we do hire a lot of people from University of Michigan. We actually, as a company, we do, I think Michigan might be one of the largest number of students, interns we're getting are now probably Michigan. Maybe University of Colorado is number 2, but I think Michigan might be the top one here. So if you're interested in internships for summer 2022, you know, please, please reach out to me. We'll be making those decisions later in the fall here, but it's always good to get started here. And also in the, probably in the fall, probably before your career fairs, we'll probably try to do try to do a resume workshop so we can get everybody's resumes up to speed in time for the career fairs. Again, so my email, my phone number, you always feel, I'd love to hear from anybody, any questions, any comments. I think we still have, what, 10 minutes here or 5 minutes after what the timing here was, to open up for any other questions.
I'll start us off for now and wait for if anyone has any questions in the chat. Both of us keep throwing around, the word passion a lot. And my question for you is, do you have any tips for young students or anyone that doesn't yet know what their passions are having trouble narrowing that down?
Yeah, that's the, and that's sort of, sometimes it's easier for me to say than to do is, and that's the neat thing about schools though. God, with the pandemic, I guess, that generation of you that are coming through this pandemic, because there's all these different events or different groups that you can get involved with to help. Because sometimes you don't, sometimes you may not, at your age, you might not know what, you sort of have these understandings of things that you're passionate about, but you don't really know how, you can't find an outlet or a group of folks to, to express or explore those passions. Let me talk in my experiences that, one of the other things, I've always loved space, period. But one of the things I wanted to do was to be a pilot. I wanted to be a pilot. I wanted to be a fighter pilot in the Air Force. But as you see, I wear glasses, and it was actually early in college, my eyesight started going. So I started wearing glasses. But back then, you couldn't be a pilot. You couldn't be a pilot if you wore glasses. It was like, oh, okay, well, I guess I'm not going to be a pilot. So I was in the Air Force RTC program. So I tried to do. I said, well, I want to do something in space. And sometimes, and I'll tell you now, I wish back then we had something like SEDS. SEDS is a great group for, and I think, as we said in the beginning there, it's open to all majors. And that's probably the other thing I really like about SEDS is because I'm actually a computer science major. Again, I love space, but it takes all majors. You can look at all the engineering disciplines, including computer science, but you need business, you even need lawyers, you need all this, you need all those groups to help, to be in space. But trying to find groups like SEDS. So, again, probably the thing I like about SEDS is it's the people who are driven about love space. But if you don't know about SEDS, how do you find that passion? But now the other side is the other thing I really, really, really like about meeting students is, or working with universities. For the most part, I'm looking for aerospace engineers. Not that we hire other disciplines, but aerospace engineering is usually is the main focus of the engineers that we hire at AGI. The neat thing about aerospace engineering is probably one of the few majors that students select, is because the reason they do it is because they've been dreaming about it their entire life. It might not have been aerospace engineering, but say, hey, I want to do something in aviation. I want to do something in space. I want to do something. And it's usually virtually every student I talk to, it's sometime in their middle school, high school, sometimes elementary school, they said, hey, I want to do that. I'm not sure what that is. Not sure what it's aerospace engineering, but they picked their path. So almost their entire life, they've been dreaming about this point that they're getting to, and they have this passion, this excitement. So the neat part about aerospace engineering, you're really like 95% on your path to what you're passionate about. Now it's just sort of trying to find that sort of that final step, and I would say that first step into like your career and everything. But think groups like SEDS is a great capability, a great tool to get, work with other students and get, hopefully, Space Vision is next fall, getting all the different university, the SEDS chapters, meeting together and working together is a lot of excitement, because you get all, you get all these passionate people about space, and getting them together, it makes things really exciting and a lot of fun. So I'm sure that's a little long answer to a short question there, but follow your dreams, follow your passion. Don't let anybody ever deter you from chasing those dreams. These are your dreams. And again, like in aerospace engineering, you've been dreaming about this your entire life. Do not ever let anybody deter you from chasing those or exploring those.
We have another question.
Okay.
Sorry, did I interrupt anyone speaking?
Nope, go ahead.
Okay, thank you. First of all, thank you, Michael, that was an amazing presentation. I really enjoyed throughout the presentation, and I'm really inspired to use STK now. Although I have a very basic question. Is the STK version available for Windows users only, or is it available for Mac users too?
Windows only. So if you're running it on a Mac, you can either boot camp, and I don't recall if some schools have virtual desktops that you can use. But yes, it's only available on Windows. You're going to find out as you go through, most of the engineering tools that you want to use are Windows only. So I mean, that's now, add a little more into that is, if you go out to industry in the engineering, in the aerospace world, there's still the vast majority of computers are Windows based.
I see. Okay. Actually, I'm an incoming grad student at UMH. So I was just figuring out my options if I want to take another system. So which one I should go for. So how likely is it to go for you?
I sort of joke with students. When I see them have a Mac, and I said, I thought you were an engineer. Why do you have a Mac for? I mean, it's not. I mean, yes, they're usable, and I don't, say, PCs are better than everything, but yeah, you'll find out. I think you'll find in the engineering disciplines that Windows machines all the software are available for the Windows machines. So Macs are great machines. Don't get me wrong there. I mean, people ask all the time, why aren't we coming out with a Mac version? The reason we don't, and I mean, it's a monetary thing, is that there are very few customers out there that are using Mac in the engineering world.
All right, Michael. Thank you so much. I mean, that helps me figure out which system I want to go for next.
Yep.
Thank you.
Any other question? Are there any other universities around the world using SDK? Virtually. So I hit basically all the top. I hit all the top aerospace universities in the U.S. Michigan being one of those. So applause to you. But yes, virtually every school. I mean, AGI provides SDK for no cost to universities to use in education. But yes, all the top universities, all the top aerospace engineering universities use SDK. So the ones that I personally work with, just like I work with University of Michigan, is Purdue, CU Boulder, Georgia Tech, UT Austin, Texas A&M, MIT, Embry-Riddle, Stanford, and there's a few other schools and things out there that I work in. But yes, SDK is from the educational. I mean, there's a lot more schools that I'm unaware of that are using SDK than I actually personally know that are using it. So I get comments from, just like a month ago, I got a couple emails from, it's interesting, it was a SEDS chapter in Puerto Rico. So they, when they reached out to me, it wasn't because they knew I supported SEDS a lot, but then I found out they were doing SEDS work also. But yeah, so yeah, there are a lot of schools that use STK. If you're in aerospace engineering, I would almost say, and you're coming, or you're at, you're looking at the same caliber as University of Michigan's aerospace engineering program, they do use STK. And it varies on how, some of them are extremely, some of them use STK, are integrated a lot in their curriculum, and some are, less so, but it is used everywhere. Great. Any other questions? I think that's my, I guess we have, well, I don't know, it looks like I have 5 more minutes, but I'm happy to answer any other questions. Or if you're unable or don't want to ask on the public forum, please, you can text me or email me with questions. I'd be happy to answer those.
In the next few minutes, I was wondering if you could talk a little bit about what an internship is like at AGI.
Okay, internships. I mean, let's just ignore COVID here. But a lot of people ask, what do interns at AGI do? Are they, are you there to make copies or go get coffee or do menial labor? If I were to hire you as an engineer, after you graduate, or if I were to hire you as an intern, and you start the exact same day, you would actually be doing the exact same thing as a college graduate that I hired you for as an intern. You're coming there, and we really don't treat you any different. I mean, it's not like one thing about, well, some companies do this. At AGI, we know you're an intern, you're here to learn. We don't expect you to know everything, or actually, we don't expect you to know anything. What we want is passion. Back to that word again. Of course, when you're a college graduate, we expect some level more. But as you come in with an intern, or if you're a full-time position, you'd actually probably be doing the exact same things. One of the things you're going to be learning our product. You're going to learning who we are as a company. But probably more, one of the things that you're going to learn in an internship, again, even if you're a full-time employee at the same time, you're going to be learning how our customers use our software. Why is our software so critical to all these different space missions? Because you got to understand, you need to understand that, and that's one thing that I think we as a company different. Well, I can talk for AGI, is that we are really passionate about space, but we are really passionate about our customers being successful in using our software. So an internship is, basically you're taking your first steps, also as an employee, to becoming more of an expert on SDK and how to take problems that our customers are seeing or customers are trying to solve, and how do we use our software tools to solve those. So yeah, so internships, it's a great learning example, and again, we don't treat our interns any different than we do employees. And you can go do as much as, I would say, hopefully, because we hire really passionate students, they generally want to do a lot more than we expect out of them. How is SDK different from GMAT? One, it has better pictures, but it's not, GMAT's it's a good tool, but it doesn't have the one thing that STK has that GMAT doesn't, is the breadth of capability. It has that long talk I had in the beginning of, sort of design to deployment of a system like a CubeSat. SDK has all that. Tell me the solar, how much illumination is my solar array doing? How often, what's the, time delay of, communications? How big of a transmitter do I need? How do I do how much delta V, or how much momentum do I need to control my satellite, to move my satellite? When can I launch my satellite? How do I, for example, actually GMAT can do this, but, one of the, I told you some of the neat missions. Virtually every mission out in space or related space is using SDK. two of the, I won't say recent ones, but they're really fun ones. They were using STK for all their trajectory design. One was the New Horizons mission. That's that one that did a lot of interplanetary flybys to get to Pluto and beyond. And the other one is the Parker Solar Probe. That's the one that flew to Venus for a swing by to start doing to fly around the sun. Again, all the trajectory design we're using STK for both those missions. So it has it's a probably more broad and a broader capability. GMAT's used in a lot of places. And so I can't, you know, I personally don't use it, so I can't give you more details there, but that's the difference there. So, okay, guys, great. Thank you for the invitation.
Thank you so much for coming. That was a great talk. It's always great to hear from you and learn more about how STK is very important to the field and how all these students can actually utilize it.